We're going to go one more step here and estimate the probabilities for many groups. So the last video, we looked at the estimate for a single group, so a group of 50 or 30 or 20 or whatever. Now we're going to estimate the probabilities for many groups, so from 1 up to this max group size, which is defaulted to 70. So that's what this function is going to do. It's going to call this function for every group that it tests. So let's just look at the code over here. So it is going to receive the number of simulations. This will be passed on to this function over here. So the first line is we're going to create a list. This list will hold the final probability estimate. So we're going to keep on appending to this list. We're then going to iterate through each group size. So from 1 up to 70. It does start at 0, of course, like you know. And so what we're going to do here is, the main thing it does here is we're going to call this function, which is this one over here, and we're going to pass it in the group size. So I starts out at 0, which is why we're going to add 1 here. We don't want a group size of 0 to begin. We want a group size of 1. That's what's going to happen here. It's going to add 1 to I, and then the number of simulations. So it's going to simulate that 100 times for that group size, and then it'll append it to this probs list, and then it'll return this list. All right, so let's just see how this works, and we'll just create a list probs. That'll be, or the a variable probs, that'll be the get whatever is returned over here. So let's not do all 70 right now. Let's just say for the first 20, and let's make a little bit more of a simulation. Instead of 100, we'll say 1,000 simulations of each. And let's go look at this. So this is saying the probability that there are 2 birthdays for a 1-person group, well, that's 0. That'll never happen. The chance that you get 2 birthdays for the same in a 2-person group is, very small. And then all the way up to, this is 20. So for a 20-person group, it'll be right around 40% of the time there will be 2 birthdays. All right, so we can keep doing this. You should see that once we get to, let's just go all the way to 40 and output this. So this would be 40, right around 89%. Now notice this one actually got higher. You would think, like, how is that possible? Well, it is a simulation, so it is still possible that they don't always just increase as you would expect, just due to randomness. That is bound to happen. If you made it 10,000, that's unlikely to happen. Just the more simulations you do, the less likely that you'll have a lower number, have a higher probability than a higher number. Okay, so that is the last step in here into just estimating all of the probabilities. So let's just summarize what we did again. So we broke this down nicely into 3 functions. The first function just determines whether a single group has a birthday that is, or 2 people that share the same birthday. This is true or false. The next function simulated this specific group size, however many number of times, 100 times by default. And then the last function went ahead and did it for all of these groups up to a given group size and returned a list of probabilities for it. Okay, so that is it for estimating the probabilities for many groups.